Hey Nathan, hey Kelsey.
Hello.
We'll get started in a few seconds once it hits noon. So I want to focus on the rates of reactions lab today. I'd also like to talk about the other one that will be starting this week. It'll be starting on Thursday. That'll be the equilibrium lab. So I'll go through a little bit of that as well. But let's look first of all at the rate of reactions lab. I'm going to share my screen here. So everybody can see my screen? Is that right? Thank you.
Yes.
Good. All right, let's, I'm not going to play the whole lab video, but I'm going to play a little bit of it because I think it's important for you to get a little bit of context as to what these times are talking about, these reaction times.
I had a question
Oh,
actually.
sure. Mm-hmm.
So pertaining to like our calculated data, I understand that you only want us to show certain parts. When we submit that to you, do you want to see though, our full workout method for all the remaining,
No, just I have got
just
this.
submit only to you that, and then the rest of our calculations can be, our own for our own reference, I suppose.
Well, they're not really for your own reference. I still want them done because I still need the numbers.
Mm-hmm.
But how you got there is not really very important to show.
Okay.
For those other ones. So these are the things that you actually absolutely have to show as full calculations. And it's just for reaction mixture 1, acetone, HCl, I2, rate, and K. Then the full calculations for M, N, and P. For part B, the predicted rate, predicted time. For part C, the activation energy and its graph. So that's it. So those are the things that I must see. Everything else, you're welcome to show them, but you don't have to.
Okay, thank you.
Okay. So yeah, I'm glad you brought that up. So I did add this general instructions for the lab here at the top of the folder. So that will give you a better impression of what you're doing here. Okay, yeah, so like I said, I'm not going to play this whole video. I'm just going to play a little bit of it because it gives you a little bit of context. And I'll explain exactly how this relates to some of the data that you're given. When you put it up like this. The problem with this is that the liquid that's in the pipette will tend to run into the bowl. Right, so the situation we have here is that in that beaker or that Erlenmeyer flask, we currently have HCl and we have acetone. And in that container at the back there, you see the iodine. Now that iodine has a certain concentration. I think it's 0.00050 or something like that. And then if you've put it into the solution, it becomes something different because we're diluting it. Because it's 10 milliliters that dilutes into 50. And that's part of the calculations that we do as well. So you'll notice that initially the solution is brownish or yellowish because of that iodine that goes in there. But understand that the initial concentration of that iodine is the diluted concentration, not what was in here. That's because it was 10 mils, now it's been diluted into 50. Now, as the reaction proceeds, I won't show the whole thing here. But you can see that as it goes, it gets lighter. And I'll just play the last part here. Right, so that's about the point at which it stops. And what we're looking at there is the disappearance of the iodine. So what happens is that it has that concentration at the beginning. Once it's put into the flask, and then it goes down to zero. That's the change we're talking about. The change from the diluted iodine initial sample all the way down to zero. Because at that point, once it's no longer colored, there's no longer any iodine present. So that's what the timing is representing here. And this is how we're going to come up with a rate. Remember that speed is like miles per hour. It's like distance over time traveled. A rate of reaction is a change in the concentration over time. Does anybody have any questions so far about that? Anybody have any questions about that? Okay. Right, so I do have in here 3 videos that I think are going to be very useful to you. One of them I actually edited last night because I had made a small mistake with one of the units on there. It wasn't fatal or anything, but it's now been fixed, just in case you were concerned about it. I'll point that out to you as I show you the video. I'm not going to show you the whole thing. I'm just going to show you what's in the video and give you an impression about what you need to be able to do here. So in your lab manual, which I'll bring up here, you have access to this too, obviously. Now, if you don't have a printer, I would say that you're going to need to hand copy these tables, but you'll need these recorded data, the calculated data. You'll need those tables there. And you'll also need access. Oops, sorry, where are they? Over at the back here, I haven't gotten to them yet. There we go. This is going to be important to you, but you don't have to put that in the actual lab notebook, but you will need this. This is going to be important for you to access. These bits of data here you'll also need. And what you'll have to put into your lab book will be these tables here. So if you don't have a printer, those are going to have to go in that way, and this table here as well. And then you'll have your other stuff here. Those are going to be calculated situations as well. And then for part B and part C, you'll need these in as well. So all of these tables here will need to be put into your lab notebook. Anybody have any questions so far? All right, so for part A, you're going to have to do a couple of things. I'm going to go back to the folder here, and what I'll do is I'll go through calculations here for part A. So here's the tables that I think you should, these two here definitely you should have in your lab notebook. You put this one in as well. I've got this here because we're going to be using this to figure out a lot of the data that goes in here. So, you know, you see here for reaction mixture 1, molarity of acetone, molarity of HCl, molarity of iodine. And it's easy to think, well, we've got the molarities up here. They're 4.0, 1.0, 0.0050. No, those are the initial stock solutions. As you can see there, stock solutions. That's before they end up getting diluted, because, you know, we have that reaction that contains all of these different things with a total volume that matches the sum of all of these. So that's what I go into here with the calculation of the molarity. All right, so that's what we're seeing there on how to do those initial calculations for concentrations. Does anybody have any questions about that? Now, in your lab notebook, let me point out what you would want to write down with that. Hang on, let me see if I can pull this up here. Here we are. So if you had that particular calculation, my thing is not on here. Let me give you a chance to bring this up. Sorry about that, folks. My second monitor was off here with the pen. All right, can you all see my screen?
Yes, it's off to the left.
Okay, good, thank you. So if we've got 4.0 molar times 10.0 mils over 50.0 mils, in your lab notebook, you would say stock concentration of acetone. And this would be volume used, acetone, and this would be total volume. So that's what I'd recommend you do for your lab notebook. I know I haven't done that in the calculations, but the purpose of that video is just to show you how to do the calculations, not so much how to set it out in your lab book. So as long as you're clear of it, that's what I'm looking for in the lab book. And you only have to show that once, right? You only have to show that for the acetone once, and then you show it for the, then you'll show it for the HCl once, and you'll show it for the I2 once. All right, let me get back to where I was here. I'm not going to play the whole thing here. I just want to give you an example. Then I go through and you can see that if this is 10 mils and that's 20, that's going to be double the concentration. And then I don't go through how to get these, but it's pretty much the same method as I showed you here. And I do the same thing here for reaction set 2 as well. And these times here, I made those up for me for here, but those aren't the times that you'll be using. You'll be using the times that are in your data, the data that's in that spreadsheet that's at the bottom of the table of contents. Is everybody clear on that? Does anybody have any questions? Everything I'm doing in this video is really just informational as to how to do something. It's not the actual numbers you'll be using. Now, the next thing you'll need to do is calculate a rate. And as I said, it's going to be the concentration of I2, the change in that, divided by the time. The time is the reaction time. It's how long it took for it to go from yellow to colorless. And as I explained earlier, this initial concentration here is not this 0.0050. It's whatever you came up with down here, which is going to be 0.0010. And then we divide that by the time, that'll give us the rate. Anybody have any questions about that? So if you were to do this in your lab notebook, show rate equals that over time, that would actually be sufficient. Then put the numbers in. That would be the same effect as labeling it, just like I showed you earlier. I don't mind that. I'll show you how the orders can be done in a second. So we come up with that for the rate. Let me see if I can get this down here. Sorry. There we go. You'll notice I got molar per second here. I forgot to add the per second here, but I did some slick editing on the video here, and I've put a /s here as well for the other rate. So that's the rate that goes down here for reaction 2, which again is based on this time and this molarity. Right, does anybody have any questions about the rate calculations for this one? Okay. See if I can move this around a little bit. There we go. All right, so this is how we're going to do the orders. And if you were to set it out, actually the way I set it out in the video, that would be totally sufficient, because then you've already got the stuff there, and then you're just subbing them in the next step. Sorry, there's things scrolling when it shouldn't be. There we go. And you can see that the data, you know, I don't put in all the other data because it cancels, and we're just left with this, and that would be fine as setting out too in your lab notebook, and setting out in the results report as well. Does anybody have any questions about that order calculation for how I'm getting the order with respect to acetone? Everybody's fine with that? Okay. Now I do go through and show you how to get the orders with respect to HCl and I2 as well. And I actually make them up for this specific one because I didn't want to give away what the actual answer was. But I'll tell you, it's not the answer that I get for those. So I came up with M, N, and P as being 1, 3, and 2. But those the 1 is actually right, but the 3 and 2 aren't right. Those are not real. But you'll have to figure those out yourself using the same method as I put down in this video here. Anybody got any questions? So the next thing we're doing is K. And again, if you want to set it out this way in your lab notebook, it's fine. You can write this out here and then sub everything in and then calculate K. Now I go through and show you how to get K and the unit for K as well. That's important. So that's all there. And I go through the math there as well and how to get the unit and how to apply the powers and all of that to the unit. So that's all in the video too. Anybody got any questions about any of the stuff that I've gone through so far? All right, so that's how we get the K value and how we get the orders and everything else that go into that. So it's pretty comprehensive. And if you have any questions about it, you know, you can ask me now, or you can send me an email if you'd like. Does anybody have any other questions about Part A? Okay. Now, Part B uses stuff that we calculate from Part A. So it's important to note that what we're doing there let me pull up this, pull this up again. This lab manual. I'll actually download it. Okay, so this is part B, and this is the data I want you to use for part B. And see, it says reaction mixture 5. See what it is? It's like this, which is 1, 2, 3, 4, and this is a 5th one that uses completely different volumes. But now that we've actually got M, N, and P values and a value of K, we can actually work with this. So that's where this data comes from. All right, so let's see. So you got the part B there, and you can see that the rate equation is this. And again, I'm using these M, N, and P values I got from before. And in order to get this rate, and the K value as well, the K value, by the way, should work for pretty much all of them. They should be very similar. It's a constant, so it should be the same pretty much for all the different reaction sets. You'll actually get an average value of K, and I think that's probably the value you'll use here. And then you can sub that in, and you come up with this as, you'll come up with, once you've got the K value we already got from the other part. And I'm showing you how to get the time there, and the concentrations as well. So now I just want, there we go. So this predicted rate here is based on the actual times that are in they're in part B in the data. And again, I don't know what times we came up with for any of that in the actual data. I just made up times here to put in here. So we have the molarities, which are worked out in the same way that we did for the first part, part A. And then we've got the time that you get from the data. And then that's how you'll get a predicted rate. Sorry. No, the predicted rate will come from from these concentrations and the value of K here. And then you'll actually you'll be able to use this time to figure out what's going on with the other thing here. So predicted rate will be based on the K and the concentrations that you calculate from over here. You see, you get to compare that time to the time that's in the data, and you'll see that when you go into it. So this, you're actually not calculating this time. You're calculating a time based on data that you've got up here, which involves these different concentrations, and then you'll be able to calculate this predicted time based on the rearrangement of this equation here. So you'll take the change in I2 over the predicted rate, which we get from here, which will give us a predicted time, which you can then compare to the time in the data. I hope that's not too confusing. Does anybody have any questions about that?
Are there any letters that are used to represent predicted time, predicted rate?
Not really.
Okay.
just, you can just write them in as such.
As words, okay.
Yeah, it's probably the best way of doing it. That way you don't get them mixed up with actual times.
All right.
All right, these are just predicted based on what we already have. All right, any other questions about part B? All right. Now part C. Part C is where you're going to have to do a graph. And I do have a video here getting a slope off a graph in MS Excel. So this is how you can actually use Excel to do that. And you all have access to Excel. You can get it through to school. So I'm hoping you all have Excel. If you don't have Excel, call up tech support and ask them how to get it. You can get it for free. You get Word for free as well. Hopefully you all know that. So that's going to be important here. But for part C, so you've got some stuff from part A that you'll be using here. But over here, you've got these times, reaction times that are going to be at these different temperatures. But you're also using the time as one of your points from reaction mixture 1, which is at around about 20 degrees or so. And then you've got these other ones that are at 14 and 40. So that makes up the 3 points. And those are the 3 temperatures you're using. That temperature, or the average of those temperatures, 14 degrees and 40 degrees, or whatever they happen to come out to be down here. And you'll notice the times here. At low temperature, let's see, the trial 1 time. I think I mixed these up. That's unfortunate. Looks like I have to edit that. That won't be as cool. Yeah, I mixed up these times. Ah, dang it. That's unfortunate. That's really embarrassing. Sorry, folks. Right, the time it took for the low temperature should have been a whole lot more than the time it took on the high temperature. Yeah, that explains that. All right. Yeah, I'm going to have to do this video again, and I will do it again. And this time I'll make sure I put these in the right slots. The result I come up with at the end, I think, is okay, where I show the graph and everything. But you know, the whole thing with the rates, that's I think that turns out to be okay as well. Yeah, it's really annoying. And I go through and I show you how to get the 1/t and how to get the k and the natural log of k. And I do that for this one here. You do the same thing down here, but I did mix these 2 around as far as what the times were. Yeah. Everything else is okay though, as far as the showing you how to do everything. All right, does anybody have any questions about those calculations, how to get 1/t or how to get the natural log of k? Well, once you've done that, you'll do the graph and you'll follow the instructions in that other video to get the graph. And then you'll have those temperatures and you'll get the 1 over temperature there. You'll calculate a k value, just as we did previously. And you'll end up getting a graph that looks something like this. And then you will get a line of, well, you don't have to get a line of best fit. You can actually get this off Excel, figure out a slope. And then that slope will be used to calculate the activation energy here, the R value you're given, and you'll be able to calculate this EA business here. Now, if you look at that slope, you'll see it's a negative slope. So what's happening is that'll be a negative number. That's a minus there. The EA should end up being positive. So that's something to look for as well. All right, does anybody have any questions? There aren't any mistakes in the actual work here. It's just when I put the data in, I put them in the wrong way. Anybody got any questions about part C? All right, does anybody have any questions at all about the calculations for the lab? Okay, well, I guess we'll leave it there for that one. I want to talk about the equilibrium constant a little bit here. But does anybody have anything else about the rate of reactions lab? Okay. So the pre-lab for this next lab will be due on June 3rd, as you can see here. So that's going to be tomorrow. The pre-lab actually itself isn't too bad. So it's asking here, it says in a similar experiment, this many mils of solution of Fe3 plus, how many moles of Fe3 plus were used? Well, in order to, what we know is that concentration is moles per liter of solution. So if you want moles of something, moles is always going to be concentration times liters of solution. So if you want to do something like we have here, we've got the concentration, which is 4.00 times 10 to the negative 4 molar, times the liters of solution, but we've got milliliters here, so it'd be 5.00 mils times 1 liter over 1,000 mils. And that will end up giving us the correct number of moles there. So you can see there what happens is that M is actually, big M is moles per liter. So the liters end up cancelling, the mils end up cancelling, you're left with moles. Any questions about question 1? Okay, question 2. All right, so, okay, so for this one, according to what you're doing in the lab, we've got moles here, and in order to calculate the concentration of Fe3 plus, we're using a reaction here. And the reaction is something like this. I think that's right. So if we know what the number of moles, it says that moles of this present at equilibrium were 2.00 times 10 to the negative 4. And we used 4.00 times 10 to the negative 3 moles of Fe3 plus to prepare it. So initially there would have been that. And at equilibrium, it was 2.00 times 10 to the negative 3 moles. You can see it's a 1:1 process. So what that would mean is that if this is the amount that was produced, it would have meant that the difference between these, what is that? Is that, there's actually should be 2.00 times 10 to the negative 4, yeah. So it would be the difference between these that would tell you how much Fe3 plus was left at the end. So if you subtract this from this, that'll give you the equilibrium value. So it'll be equilibrium Fe SCN2 plus. It's very similar to what we did in the class for that K question when we're doing that. So that's the yeah, that's the equilibrium value there. And yeah, like I said, we can get how much Fe3 plus is left by getting the difference between those two. Does anybody have any questions about that? I won't go through that. You can do it yourselves.
So that equation or that chemical reaction is not what is discussed in the actual lab. It's different elements, but you were able to come up with an equation. Do we need the equation to complete the question? I mean, do we have to come up with a chemical equation first?
No, you got it. No, you are given the equation here. Let me show you. So you know it is a 1-to-1 ratio. There it is there, Rebecca.
Okay. Does yours show what page that is? Your screen?
31.
Okay. I think maybe I'm a little bit confused on how far this goes because I stopped this lab at page 30 because it had a second purpose. So is it?
Well, this isn't, maybe you mixed up in the two labs. This is a separate lab here.
No, I understand that.
Okay.
And then you start the new lab that says equilibrium right there on page 23.
That's not the lab we're doing here. This is equilibrium constant calculation. That's the next lab. This one.
Okay. So the one that you just skipped over, the 23 to 30,
mm-hmm.
which one is that according to the table of contents?
That one is well, it's the one we do after pH. I can't remember the name of it.
It just says equilibrium, I think. Hold on.
Yeah, it might be. I know it's kind of confusing because they both have similar names, but I'll show you how to get around that. I didn't want to leave the pre-lab here though.
No, I understand. Okay, so the way it's written in the lab manual is not the order that we're doing it in the class.
No, it's not.
Okay.
But it's in the experiment schedule. So that's what I was going to point to. If you look at the experiment schedule, it tells you exactly which lab is which and what the titles of them are.
Yeah.
But anyway, that's the one we're doing. We're doing this one here, equilibrium constant determination.
Okay.
All right. So please refer to the graph in the lab document. That's this one here. And it says here that the absorbance was found to be 0.7500. What's the concentration of the solution? So what I'm asking you to do is, here's the absorbance here. Run the absorbance across to this line and then come up with the concentration. That's what you need to do. So that's for question 3. Anybody have any questions about that? Okay. And for this one here, you're looking for Kc, which is K versus K based on concentrations. And again, you're using this formula here to do that. You do have all the data. You can just do the math on that. So it's not too bad. All right. Does anybody have any questions about any of those pre-lab questions? Okay, that's pretty much all I wanted to show you. Rebecca, I'll point out this experiment schedule thing here, and I'll show you. Yeah, it's annoying. I'm sorry that they're not in the same order. I kind of wish they were, but
the words are extraordinarily similar.
I know. I know.
I mean, so, one says equilibrium and one says equilibrium constant.
Yeah. Yeah, I'll just show you the thing here. So you've got spectro here, lab 4, and then down here it's got determination of equilibrium constant. And then of course these are in the correct order. The things in the actual table of contents, they go in the order that we do them.
I think I probably was confused too, because we're doing the other one in the lecture class right now. So I thought they coincided.
Right.
Mismatched.
Yeah. Well, I mean, we do both. We're doing both. I mean, if you look at question 4 of the test, that relates very much to what we're doing here. We're figuring out K. Yeah.
Right. Right.
So we're kind of doing both things. And I think the only reason that the other one got moved, because it did get moved, is because we don't do solubility product till the next test. So I think that people didn't want they didn't want people to say that we hadn't done it yet. So that one got moved. All right. Does anybody have any questions about either the rates of reactions or the equilibrium constant determination? Anything at all? Okay. All right. Well, we'll leave it there for today. And if anybody has any questions, send me an email. All right. Well, thanks for coming. I appreciate it. I'll see you all next week. Have a good day.